All right, let's dive in. Today we're going to pull back the curtain on one of the most talked about and maybe one of the most misunderstood technologies out there, artificial intelligence. When you hear AI, your mind might jump straight to sci-fi movies, right? Robots and spaceships. But the reality is, it's everywhere. And I'm willing to bet you've already used it a handful of times today without even thinking about it. Think about it. When you unlock your phone with just a look. Yep, that's AI. That movie Netflix just knew you'd love? AI again. Asking Siri or Alexa about the weather, or having Google Maps tell you exactly when you'll get home, even getting help with your code from GitHub Copilot. All of that is AI working silently in the background, just making things run a little smoother.
Okay, so that begs the question, right? What exactly is artificial intelligence? Well, if you boil it all down, it's really about one thing: teaching machines how to think.
So let's get a good, solid definition on the table. Artificial intelligence, or AI, is basically any tech that helps the computer do something that would normally require human smarts. We're talking about giving machines a taste of our own cognitive abilities.
And what kind of human smarts are we talking about? Well, stuff like spotting patterns in massive amounts of data, or understanding what you're saying when you ask your smart speaker for a song. It's about looking at a photo and knowing there's a car in it, or even reading a license plate. And maybe the biggest one of all, taking all that info and actually making a decision or a prediction.
But here's the thing. To really get what's happening with AI today, we need to pop the hood and look at the engine that's driving almost everything. And that engine is called machine learning.
This is where things get really interesting. Machine learning flips the script. Instead of a programmer writing a bunch of rules for the computer to follow, the machine learns the rules on its own, just by looking at data. And believe me, that shift is an absolute game changer.
This really breaks it down perfectly. Think about old-school programming. A person writes the rules, you feed in some data, and the computer spits out an answer based on those rules. Simple. But with machine learning, you turn it completely inside out. You give the computer a ton of data, and you give it the correct answers. The computer's job? To figure out the rules that get you from the data to the answer. It's learning the logic all by itself.
So how does this actually work? It's basically a two-step dance. First, there's the training phase. This is like the study session. The AI model just pores over tons of historical data. Let's say a bank shows it thousands of past loan applications, pointing out which ones were paid back and which ones defaulted. Then comes step 2, inference. This is the test. The model, now trained, uses what it learned to make predictions on totally new stuff, like looking at a brand new loan application and deciding if it's a good risk.
Okay, so we know machines learn from data. But how? Well, it turns out there are 3 main ways they do it. We call them supervised, unsupervised, and reinforcement learning.
Let's start with supervised learning. The best way to think about this is like learning with a teacher or with flashcards. The data is all neatly labeled. Every email is already marked as spam or not spam. The AI's goal is just to learn the pattern so it can label new emails correctly. Then you have unsupervised learning. This is the total opposite. It's like being thrown into a library with no catalog system and told to figure it out. The data has no labels. The AI just gets a massive pile of, say, news articles, and it has to find the hidden structures itself, clustering them into topics like sports, politics, or tech.
And that brings us to the third type, which is honestly my favorite one. Reinforcement learning. It's just like training a dog, seriously. It's all about learning by doing, trial and error, with a system of rewards and punishments. And this loop shows you exactly how it works. Let's use a chess-playing AI as an example. First, the AI makes a move. That's the action. Then it gets feedback. Was that a good move? If it was a great move that put it in a better position, it gets a reward, a little digital treat. If it was a terrible move, it gets a penalty. It does this over and over, millions and millions of times, constantly adjusting its strategy to get the most rewards possible. And in a game of chess, what's the ultimate reward? Winning the game. All right, we've covered the basics. Now let's go even deeper down the rabbit hole. Because the stuff that's powering the most mind-blowing AI you see today, that's a special kind of machine learning called deep learning. And its design? It's inspired by the most complex thing we know of, the human brain. But wait a second. How on earth does a machine learn from something so incredibly messy and complex, like a picture or the sound of someone's voice? It's not just simple numbers in a spreadsheet. The answer is something called a neural network.
So neural networks are basically computer models that are built to mimic the structure of our brains. They have layers upon layers of interconnected neurons that process information. And that deep, layered structure is the secret sauce. It's what lets them tackle really complex, unstructured data, the pixels in a photo, the sound waves in your speech, and find patterns that older, simpler methods just couldn't see.
The way these networks learn is pretty cool. It starts with what's called forward propagation. All that means is that data, let's say an image, flows forward through all the layers of the network. At the end, the network makes a guess, like, I think this is a picture of a cat.
Okay, but here's where the real magic happens. It's called backward propagation. The network checks its guess against the right answer. If it guessed cat, but the picture was a dog, it calculates how wrong it was. Then, it sends that error message backward through the network, tweaking all the connections just a tiny bit, so that next time, its guess will be a little bit better. Now, imagine it doing that millions of times. It gets smarter and more accurate with every single pass.
Okay, so all of that, machine learning, deep learning, neural networks, it all leads us right here, to the absolute cutting edge. This is the stuff that's been in all the headlines, the technology that has completely captured the world's imagination. We're talking about generative AI.
And this really is the fundamental shift. For a long time, AI was all about analyzing things that already existed. It was about predicting. But now it's about creating.
So what is generative AI? It's a kind of deep learning, where the models don't just classify or predict things, they actually generate brand new, original content, text, images, code, you name it, that looks a lot like the stuff they were trained on. This is exactly what's behind tools like ChatGPT or Midjourney. They're not just finding patterns anymore. They're using those patterns as a recipe to cook up something totally new.
And the number of tools that have popped up is just mind-blowing. For text, you've got ChatGPT, Gemini, Claude. For whipping up incredible images, there's Midjourney and DALL-E. We're even starting to see AI that can create video, like Sora, or that can write code right alongside you, like GitHub Copilot. It's safe to say generative AI is changing creativity in, well, pretty much every field imaginable.
So there you have it. We've gone all the way from the simple basics of AI to these incredibly powerful, creative models we're seeing today. What's clear is that these systems are learning from a digital version of our entire world, which leaves us with a really big and really important question to think about. Now that we've built it, what do we want it to become?